So we are going to prove of the first identity. Sine A plus B is equals to sine A cos B plus cos A sine B. To prove this, we have to consider two angles. Suppose this angle is A and this angle is B. So what will be this total angle?
A plus B.
This will be A plus B. Suppose this is point O and let's say this is P. This point is Q. And from R we draw a perpendicular to Q, to OQ. This angle is 90 degree.
So which angle is 90 degree?
This angle. We have drawn a perpendicular
Okay.
from R to the line OQ,
Yes, sir.
right? And we will also draw vertical perpendiculars from R and Q respectively to OP. And let's draw a horizontal line from Q. Now, can you tell me what will be this angle? Since these two are parallel, this angle is A. This angle will also be capital A.
Yes, sir.
Alternate interior angles. And if this is A,
Uh,
this will be 90 minus A. Right?
yes, sir.
And since this is 90, this angle will also be capital A.
Yeah.
Right? Now let's start with what do we need to prove. We need to prove sine A plus B. So let's start with what is sine of A plus B. Can we identify a right angle triangle from this figure and find sine of A plus B, this complete angle?
Yes, sir. So we have the right angle triangle with the line vertical line R that touches OP and
X, OXR.
yes, sir. OX and
So
yeah.
from this triangle, what will be sine A plus B? Rx upon OR?
OX.
No, that is tan.
Mm, Oh
Sine is
yes, sir.
opposite over hypotenuse, right?
Yes, sir. Yeah.
And Rx can be broken down into, let's say this point is Z, RZ plus XZ,
Yes.
and OR can be written as it is. Now we can split this into two parts, RZ over OR plus XZ over OR,
Yeah. Yes.
right? Now you do RZ over RQ into RQ over OR. In this ratio, we multiplied and divided by RQ, right? And in this particular ratio, XZ over OR, we multiply and divide by OQ. and let's see
So,
what
but like
happens.
how would one had identified that we were supposed to do this, like multiply by and divide by r cube?
Because I am thinking a little ahead,
Oh, okay.
right? The moment you write the next step, you will understand why we did that. Now, what is
Yes.
RZ over RQ?
R0. It's
Isn't it cos A?
it's tan 90 minus
No, no,
tan 90 minus a.
no. RZ over RQ is, look at this angle A with respect to this.
Sine 90 minus a.
And instead of sine, let's talk in terms of A. So it will be cos of A,
Okay, yes, sir.
right? And what will be RQ over OR?
RQ.
This is capital B. So RQ is the opposite and OR is the hypotenuse. Isn't it sine of B? RQ
Yes,
over
sir.
OR,
Yeah, yes, sir.
right? Now it is matching with what we want to get. We wanted cos A into sine B and we got cos A into sine B,
Oh, okay. Yes, sir.
right? And XZ over OQ, XZ, we can replace actually XZ by QY over OQ and OQ over OR. Let it be as it is. Now what is QY over OQ? Isn't it sine A?
It's yes, sir.
And what is OQ over OR? It's cos of B.
Yeah, yes, sir.
So cos A into sine B plus sine A into
Plus
cos
sine
B
cos.
is sine A plus B. So once we have written sine A plus B, it is easier to break like this. But if you apply a little thought, you will know that we need to find cos A sine B, sine A cos B, and cos A will include RZ over RQ, right?
Yes, sir.
So we need to divide and multiply by RQ. And sine A, if I need to have sine A, then it has to have OQ in the denominator, because OQ is the hypotenuse in the triangle in which A is this angle. So that's why we need to
Yes, sir.
multiply and divide by OQ. So we need to multiply and divide by OQ, and we need to multiply and divide by RQ. Basically the base and the perpendicular of the triangle OQR, and rest everything will follow automatically.
Yes, sir. But from this, how do we explain the case for sine A minus B?
That is very easy. If we just replace B by minus B in this identity, we will get the other identity.
Oh, but won't we get like cos
Let's
A
see.
sine minus B plus sine A
Yes,
cos
cos A,
minus B?
cos A into sine minus B plus sine A into cos minus B. And we know that sine of minus x
Yes, sir.
is equals to minus sine x from the unit circle. And cos of minus x doesn't have any
Yeah,
impact. It
yes.
remains cos x. Therefore, we get a new identity. I will write this term first because this is positive. We get sine A cos B minus cos A sine B. This is sine A minus B.
All right. Yes.
The easy way to remember this is we need to have alternate sine and cos. Sine, cos, and cos and sine. AB, is it in order? That's it in order. And if it is plus, then we also have plus here. If it is minus here, we have minus here. Right?
Understood.
And there is another pattern, similar pattern in, not similar, but little, there is some pattern here in cos A plus B. It is cos A cos B and sin A sin B. If it is plus, then we have minus. If it is minus, we have plus. Right?
Yes, sir.
Now, how do we find cos A plus B? If we can convert sin A plus B into cos A plus B somehow or not?
Um.
I think we can.
So, co sine 90 minus x is equals to cos x, right?
Very good, very good. We can use that. You are thinking in the right direction. So if we start from cos A plus B, we can write cos A plus B as sine of 90 minus A plus B,
Yes, sir.
right? And probably we can consider sine 90 minus A as one angle and minus B as the other angle. And let's apply sine x minus y by using this identity. And let's see what do we get. We can apply sine x minus y. That
Yes,
is
sir.
sine x cos y minus cos x sin y. And x is 90 minus a. And sine 90 minus a will be cos a. Y is b.
Yes,
B minus cos x cos 90 minus a is sin a. And y is b. So we get sin b. So we have proved cos a plus b is cos a cos b minus sin a sin. And
yes,
similarly, if you want to prove cos a minus b, just replace b with minus b. The first term will not have any difference because cos of negative b is b itself. And minus sin a sin b will become plus sin a sin b.
yes, sir.
Because sine of minus b will be minus sin b, minus minus will become plus. So this proves the second identity, of course. Right.
Understood.
Now, how do we prove tan a plus b? Tan a plus b can be written as sin a plus b upon cos a plus b. And what is sin a plus b? Sin a cos b plus cos a sin b divided by what is cos a plus b? Cos a cos b minus sin a sin b. Now, if we divide the numerator and denominator by cos a cos b, let's do that. Divide the numerator and denominator by cos a cos b. Sin a cos b upon cos A cos B plus cos A sin B upon cos A cos B,
But why do we want to divide by cos A
because we need
cos
to
B?
bring tan A.
Oh, okay,
And tan A
yes.
as the first term will only come when sin A and cos A comes, and cos B will get cancelled.
Yes, sir.
And similarly do the same in the denominator. Rest everything should follow automatically. Cos A cos B upon cos A cos B plus, not plus, minus sin A sin B upon cos A cos B. Now if we can quickly
So
simplify
then we
this,
get, yes, so then we get 1 in the denominator, 1 minus,
tan A
um,
tan B,
yes,
tan A plus tan B, because here cos A cos A gets cut, here everything gets cut, and 1 minus tan A tan B. And if you replace b by minus b, the sign will get flipped. Numerator will
yes,
become tan A minus tan B, and the denominator will become 1 plus tan A.
understood.
So this is a very easy proof of all the compound angle identities.